All right, this is Mr. McMurray, and we're here for the Ramp It Up Lab, okay, for physics today. And so I just say physics and remind me what class I'm working on. Okay, so we're going to do a ramp lab. We have a vehicle here, which is our car. Let me just blow this up a little bit so you can see what I'm talking about. All right, so we have a car right here. This is our cart. Okay, it has 4 wheels and blue, not really necessarily splashy one that you would, buy for hundreds of dollars. That thing. All right, now with our cart, we are going to have a ramp, and the ramp is going to. Good. All right, the ramp is going to. We're going to run the cart up the ramp. On the side of the ramp, I don't know if you can see them very good, but there are markings every so often on here, every 10 centimeters, okay? So 10, 20, 30, 40, 50, 60, 70, 80, and then finally 90 at the top here, okay? And so we're going to try a ramp, which is a simple machine called an inclined plane, all right? And we're going to put it on this pack of books and lift it these different distances. Okay, and we're going to see how much that affects the amount of force compared to the amount of distance, and therefore the amount of work that's done. All right, now I'm going to pause it for a second, get some stuff together, and I'll be right back. But you won't know that because you'll still be there. All right. Whoops, maybe not. All right, so here we are, and we have a meter stick. And let me get back to my big view thing so I can see what you can see what I'm doing. Okay, all right, and we're gonna poke it back down where you can see down what's going on over here. Okay, so the first thing we're gonna measure is we are going to use the ramp to lift the cart up 5 textbooks. Okay, well, we're gonna measure how high that is with our thing here, and it's gonna be about 19.1 centimeters. But we want to do this in meters, so we're going to change that to 0.192 meters, and that will go on your worksheet. Let me show you real quick, right here, okay? So that will be your resistance distance. That's how far we're trying to lift our cart, okay? So we're going to make that 0.192 meters, and you can fill that in all the way down. I'm not going to right now because I've got I don't have time. All right, so moving on. All right, now we are going to put the ramp at different heights. Okay, the first time we are going to make it at 20, but that'd be straight up and down. So we're going to do it at 30. Okay, at 30 centimeters. All right, so there's 10, 20, 30. It's going to be at 30, so it's going to be a 30 centimeter ramp to go up 20. Then we're going to put it at 50, and then we're going to put it at 70, and then finally we're going to do it at 90. So that is going to be the effort distance. We're going to put effort to pull it up the ramp, so that's going to be our effort distance, okay? And so for our effort distance, we're going to put that here. So let's put 0.30 meters, 0.50 meters, 0.70 meters, and 0.90 meters, okay? Because we're going to change that each time we do it. So I'm going to do the first one, and I'll let you type in the others. Okay, 0.30 meters. Okay. All right. Now, the resistance force is going to be the weight of the object. Okay, and so we're going to take our cart here and find out basically how much it weighs, because that's the weight that we're going to try to move with this. Okay. So I'm going to put it on my, I don't know, gray scale, one of those things. Stop being colorblind, what can I say? But whatever. We're going to put it on a little scale here and see how much it weighs just by itself, okay? And if we do, it comes down, we're going to do it in newtons. So it's going to be about 4.7 newtons, okay? Now, it is always going to weigh that much. So we're going to put that down. You can put that down all the way down the thing. So 4.7 newtons, and that can go all the way down in all 4 of these blanks. Okay, now the effort is going to be different each time as we do that. And we're not going to worry about any of the formula stuff yet. We'll do that later. All right, so let's set this up. See if I can do this without hurting myself. Where it's 30 centimeters or 0.30 meters effort distance, and how much force it takes to pull it up there. All right. Now, if I can do this with one person, we will see. It's kind of tough, okay? But I bet I can do it, because Mr. McMurray is like, there you go, like Superman, that's right. Okay, so here we go. I'm going to put it right up there. Okay, and I'm going to lift it up there. Now, it doesn't have to, you can go up here higher, it's okay, but it's going to be there. So, you do it in newtons, so it's going to be about 3.05 newtons, okay? So, is it easier with a ramp? Yes, it is, okay? Instead of 4.7 newtons, I only had to do 3.05. Whoops, did not click on there. Hang on, let me check here. Okay. 3.05 newtons. Okay, so it took less force to do it, and that's good. All right, now we're going to go to the next one. All right, the next one is going to be 5, or 50 centimeters. Okay, and this is going to be hopefully a little bit easier. It'll stay in tune there. All right, I'm going to switch out for a more precise scale. All right, for this one, and it's going to be at about 1.70 newtons. Okay, so 1.70 newtons. Doing this kind of in a hurry, so I hope I'm doing it accurate, but we'll see. All right, so for this one, it's going to be 1.70 newtons. Okay, keep in mind this is going to be 0.500 meters. Okay, because it's 50 centimeters. All right, now we're going to do it for 0.7d or 0.700 meters. All right, which would be 1, 2, 3, 4, 5, 6, 7. All right, about right there. All right, we're going to pull it up, and it's going to be about about 1.15. Okay, so that's going to be about 1.15 newtons. All right, and we're going to do one last one at the very lowest. All right, very lowest, which is 90. All right, and we're going to pull it up. Get on track here. All right, we're going to say 0.85 newtons. All right. Now I realize I'm doing this kind of quickly, so hopefully I'm still doing it accurately, but we'll see. Okay, and so like I said, this would be 0.50, 0.70, 0.900 meters. Okay, this is the same all the way down. This is the same all the way down. But you notice that the farther the distance is, the more lower the ramp is, basically, then it takes less force to pull it up. Okay, now the formulas here are, if you take, it tells you how to calculate each of these. If you take the resistance force, Fr, right here, that's the 4.7, divided by the effort force, that will give you the mechanical advantage, or how many times it multiplies your effort, or how many times easier it is to do it with the ramp. Okay, now that's your actual, how much force it took and so forth. But we can, in an ideal world, we can figure out by doing the distances, but we do the opposite of the distances. We take the effort distance, because it's going to be bigger, and divide it by the resistance distance, which is the 0.192 meters. Okay, so it's going to be this divided by that, this divided by that, this divided by that. That gives us the ideal. If we did this right, the ideal should be higher, and then the actual should be less, because we have friction and problems like that. But sometimes, because of inaccuracies in our scales and stuff like that, they may not work out that way, but we'll see. All right, the work input, the work I did, so it's the effort force, which is this, times the effort distance. So effort force times effort distance times effort distance. And the mechanical advantage has no units because newtons divided by newtons, the newtons cancel. It's just a number. It tells how many times easier it is to use it. But the work input, since we're doing newtons times meters, should be in newton meters, or we know newton meters are also equal to, that's right, joules. So you can either do it in newton meters or joules for your answers. The work output is going to be the resistance force, how much it weighs, times the resistance distance. Okay, and that will go here. All right. Then to find out the efficiency, we take the work output, which is this number, divide it by the work input, which should be a bigger number, hopefully, if we did it right, but sometimes it doesn't work out that way. And then that will give us a decimal and then times 100 to tell us what percent efficiency our ramp had. Okay, then using that, hopefully you can use that to answer these questions down here, and then you may submit your document. All right, hopefully that all goes well for you, and we'll see you next time, and have a great weekend, and we're done here.